same, I'm importing pandas. Firstly import pandas and then numpy with the alias pd and np. Then the standard stuff I'm creating with using range and index. So index here I'm specifying as ed random index specified. Okay, so this would yield a series object which has shuffled index and these aligned values. So what now we want to do is we can just use s.sort index, and this will sort index based on like their ASCII value. So if these are uh, characters, this will based on the ASCII value, it will sort down. If these are let's say numbers, then it will be, sort those based on that. Cool. So this is a simple sort functions. Right now we have applied it on the series object. Now we have creating the same data frame using NP range. This will give a list of 12 integers. We are reshaping them with the 3 rows and 4 columns. Column names we are specifying here using that columns. So index we are specifying here as 2, 1, 3. This is the data that we got, data frame that we got. Now we will use the sort index to the data frame. Here we have used it on the series object. Now I'll be using that on the data frame. So has sorted based on the ASCII value, as I said. So this is the index, right? So if you see here, so 1 is at the top, so 1 comes O comes before T in the alphabetical order, and T are same here, so H comes before W, so that's why this came before that. Okay, so this is sorting based on the index. Now if you want to sort based on the columns, uh, like you can have specified. So by default, if you see here, you have an axis as a 0. That means it will sort based on the index, right? Index is nothing but the names of the rows, right? Records. So each row we will call a record, or let's say entry point. Okay, so if you specify axis as 1, then it would sort based on this. So earlier we have DABC, now we have ABCD. Okay, so and all of these are not in place. That means our original DF is still the same, right? We have not assigned this to the original data frame. So original data frame is intact. Okay, so moving forward, we are sorting index, and now we can specify ascending equal to false. So by default, ascending is true. So we are explicitly mentioning that ascending should be false. Press enter, and then we got DCBA. This is axis 1, right? So we got DCBA. Same can be done index, I guess. 2, 3, and 1. This is how stuff works. Now coming to the other example, so this is the sorting based on this uh, index and the column headers. Now we will take look how to sort based on the individual values inside the columns. Okay, so I'm defining a new data frame, that is df2 data frame 2 pandas.data frame, specified column header and the array, same column header and the array or list, and now I press enter. We got df. Now what we want is we want to arrange our records, these rows, based on the values present in the B, right? And by default ascending is the 2, right? So we would see B is sorted based on the, so this whole data is sorted based on the values inside the B column, right? So you're seeing -2, 0, 1, 1, 5, right? So, and if you look at this, this is the index, right? The original index 0, 1, 2, 3, 4. This got also updated. I would say like changed. So 0 now comes here. This remains here, but based on that, it is changed. Okay. Now if we want to sort based on the two columns, like this is the one, right? So I'll specify it directly. But what if we want to sort based on the A and B and A? So if I did that, so if you see here for the 0, now -1 comes before, so this record got interchanged. So first preference is always given to the first one, that is a B, and then if B values is same, then second preference would be given to the A, right? So A column. That's why we are seeing in this way. Now, so let's do the same stuff practically on the column on the database, that is BD sales, like the sales of the games that we have. So this is how our data looks like, and so sort values name. So here what we are doing is we are sorting values based on the name. Okay, so I'm doing this, and you see here this has a chunk data. So this is what I was referring to. So these comes before in the ASCII characters. So that's why we are seeing here as like this. So if I said here false, then I would get it as an like in the opposite order, like we were seeing here U, W, and this. I think this is some extra character, like special character we got here. Okay, cool. So you get the idea. So this is based on the name. Now we want to sort it. If we want to sort it according to the year, you can see here 1980 is the first year, and like we are getting this database on that. Yeah, so none value is ignored, so these always comes at the last. So if you see here, year data is so what it do is it will sort values according to the year values, but if this column has a nan value, like the blank value, then it would list all those as to the end, like append it to the end. That would always come like the end of the data frame. Okay, same like if you want to sort it based on the let's say like two columns, same stuff. So first reference is given to the year, then name. So 1980 and A, so name goes with the A, then B, and then C, and then D. Same goes with the every other year. So this is generally how to sort these data frames based on the columns, based on the index, based on the column headers. Okay. So let's start with the this we can. This is mostly part covered, so you can skip that. So this is something that I want to tell. So the dataset that I shared has a multiple .txt files, right? So this is data.txt, this is data2.txt, and I think we are using 4 till 4. Cool. So let's start the first. So okay, this is .txt file. That means this is not standardized. So if you see the CSV file, which one should I see? Okay, this one is big. Okay, let's have this. Yeah. So you are seeing this as an formatted file, right? This is looking quite good. But same is not the case with this one, right? That is because txt format is not standardized. That means I can write anything, any stuff can come in. But here we have a comma separated value. There will be those two will be separated using the comma. That distinguish this CSV file, that is comma separated values. But it is not always the case that you will always get the data in the CSV or the Excel format, right? like we can have a text data, we can have Excel, we can have CSV, we can have pickle files. We need to address all of the stuff, right? So this is what this notebook will like going to talk about. So we have, let me clear that first. Importing pandas and numpy, then starting. Okay, so here I have read it from the .txt file. Okay, so here I'm not using read CSV, I'm using read table, and by default, if you see, if I type comma here, so its delimiter is set to none. Okay, that can be str. Okay, it's none. So that basically means is if we have a tab or a space, then it would be treated as though values as a separate. So you see here we have a space, and here we have a space, here we have a tab, right? So these two values are, every value that is separated by a tab or a space is treated as a two different values. So this is what read table will do. So if I run this, we'll get perfectly balanced data frame. But if I do this, you see here like we get the bad formatted data frame. So this is not three columns, this is a single column. So if I type here the f2 dot, you're seeing here like this and this like this whole is treated as a single value, single column header. And remember these are okay, so this is data 2, this is data 2, right? Yeah. So we don't have a column headers here, right? So this, so our read table function just read this as an header, but this is not a header, this is a record, right? This is a name, so we need to address that as well. So what we do is we would specify in the coming example. So here we are saying like separation. So separation or delimiter, like it's one and same thing. So we are telling like separation is comma. So that means separate values using commas. So if I do that, I'll get a properly formatted data. But the issue is still, right? We are seeing the first record that here as a column header, but this should be a record, right? This should not be the header. So that we need to address. So I think that's repeated. So now I specified header as none. That means I don't want first rows to be treated as a header. Okay, so I specified header as none. Then all of the, so by default it gave numbering 0, 1, 2, just like the index. It also gave columns the name that is 0, 1 and 2. So this is what I got. That back. If I specify header none, we got the complete all data inside as a row, not as a column header. But let's say I want to have those names, then the same I can specify names is equal to this, and headers is none. So it would itself will give this name, that is name score in text, that is done. So now here we have index as a default value. That means 0, 1, 2 and 3 and 4 is given, right? So we don't have a say to choose our index right now till this point. But let's say I want the name column to be acted as a index. So I just mention here index underscore column, that is name. So from my existing column names, I can select any column and make it as my index. Now you see here, so 0, 1, 2 and 3, 4, 5, this is gone, and a new index, that is name column, that is treated as an index of this data frame. Fine. So going forward, now let's take a look at the data 3. What does it say? And so it has all the column headers and the values. So why I'm doing this as a data 3. Okay, so I'm referring this as 3. Let me correct that. we got data, and so data 3 is in a proper format, right? It's a kind of a CSV format, but still it's in .txt file. So we just specified here, like this is separation is this, like delimiter is this, and you read this data, but we have used read table, not read CSV. It's still in the .txt format, right? So we have read this, we got the nice looking data frame, and now we want to specify the index column. So in that tree, so separation this and index column, again I'm specifying. So now what? So I specified two columns. Earlier we have specified one, right? Name. So now we got two index. So that means every record has to go, like first need a like for example, so we are doing the lesson and the name, right? Lesson and the name. Yeah. So for math and stat. So for math we have Kim, Tim, and Tom, and same like stats way we have Kate, Alex, and Sam. So this is what this is referring. Like math, first index is math. Math index has these names. Stat index has these names, which have these two values, like these two column headers. So this is basically used in the group by functions. So let's say you want to apply operations by first grouping two columns. Let's say you want to group columns based on the subject. Like here we have lesson. So let's say you want to find the average marks in the maths, right? So you first group it by the uh, uh, like the column lesson. So lesson column you will group by, and for every grouping for maths stats you will just have the score. Let's say if you have a score here, then you will just tell like what is the average score that a student scored in the maths. So like that. So group by feature is like pretty useful. So in the data 4, so this is also, so yeah, this is the junk data which I was like wanted to talk about. So you see here, this is the main record that we have. This is the column headers that we have, and these are the junk data like that we don't want, right? So line 1 and line 3. So if I try to directly read this as in data 4, I would get this data in the like data frame in the bad format. I got the first column as a hash hello and the second column as hash score of students nan, right? So this is not useful. So what I can do is I can have a skip rows function. So I would say like you need to skip rows 1 and rows 3. So this is what I'm doing here. So index start is 0, right? So you need to skip the first row and the second row. Third, I mean. First and the third one. So this is what we are referring it, first and the third. And if we do that, we will hopefully get the nice looking data. Yep. So we are getting the nice looking data. So you see, like we are not limited by the CSV or the Excel. Any type of data that can be represented in the table will be represented in the table using pandas. Pandas have all the functionality to modify and skip the stuff. So now say this one, we are skipping rows like that, and like the earlier that we did, like the first one and the third one. Now what we are referring is the use columns. That is okay, so first and the second column, that is the name and the score. So we want to omit the third column, so we can just specify we don't want the third column, we just wanted the first, like 0th and the first column. So we got name and the score. Like every part you can customize and like have according to your need. You can also specify the number of rows that you want. If you don't want the old rows, you just want 5 rows, 3 rows, 2 rows, you just specify here. You can have that. Now, so pandas is just not about the reading data. Okay? So let's say you have worked on feature engineering. So let's say you have a complete like big data, you have been working on it like 2-3 days, you have all your code running, you have applied that technique, that everything. So what now? Like every time you need to use that output, what would you do? Like should you run like all the code from the start to the end again, and like all the processing and all the time you would spend? So what we can do is, आपने जो भी डेटा प्रोसेस कर लिया है, like अभी तक कोई इंसाइट निकाल लिया है, for example this is the final data, so from this junk data I have extracted this, right? We say this part, right? So this is the final clean data. So what I will do is I will save this as another CSV, so that I in the future, if I wanted to use this, I can just directly read the like the clean data. I should not go with the from the start, like do the reading, skip those rows and do all the stuff. I can just save it, and that saved CSV or text or any format that you will save, you can use that in your future references. Okay, so this is what we are doing here. So let me save that. I want to showcase some of my other stuff as well. So this is the data frame that we have, right? So what I'm doing is df4 to CSV. I would save it datasets, new data. Today is 12th. It's CSV. See here, I'm saving it as a CSV, and let's remove this one so that you will get the understanding. I did that. It got saved. I'm going back to the folder. I think it was right. Yeah. So see, you get the CSV file generated. So this is generated 14 seconds ago. So if I click that, now you will see here we have 0, 1, 2, 3, 4 index, right? So when you saved it using 2CSV, this column also gets saved as a blank. So this is unnamed column. So this is the issue. I don't want this column, right? So index, so whenever we read the data frame from the using Python will always add its own index. Then I need not to save this with this index, right? So I don't want that. That is the reason I have index is equal to false. That means while saving to this, I don't want this index to be saved. I just wanted my entire columns to be saved. I don't want index. Okay. So if I did this and I reload it, I think I need to go back. Yeah. So I don't get now that extra index column. So that covers the part of saving the, like writing the cleaned data frame to the CSV files, Excel files, or any of the stuff. Okay, so now moving on to the most important notebook, that is to handle the missing data. So kernel start. Just a moment. So so our whole discussion started with the missing data, right? So what you would do if you have a data missing, right? So let's say we have rows, like let's say tens of thousands of rows, right? But some of the data is missing. So what you would do, like so for example it have 10 columns. Okay, let's say 10 columns. 9 column have value, but 1 column has a missing value. Let's say this example. So this has a missing value, but these are like the useful value that we have, right? So what do? Like you would want to remove all the data that have like any of the blank value, like either this, that, or like, so if any of the column has a blank value, do we want to remove them? No, because those information, those data point would be lost. We don't want that. We want like we should have as much as information as we can from the data frame. So we will deal with this in the data frame then. So okay, so kernel, but restart and get output of each cells. Yeah, so this will give you the count of the null values, that is like 1, so one is null here, and not none, same stuff as dot not null dot sum. So the complete summation that you will get here. Okay, so now what we are doing is we are intentionally assigning the third index as in none. This would tell this is none, right? So it does this drop none. So this got, so I assigned the third value as none, right? So first let me print assign then. Now this is how our series data looks like, series object look like. Second one is NaN, the intentional NaN that we created, and this is the none. Okay, these both are treated in the same way, right? So if I do is none, this, then I'll get on the first and on the third, I'll get the true. Okay, so if I did drop now, that means drop all those records which have null values. So this is dropping this record off. So I did a drop now on this series data, right? And drop now. That means the one that has NA, those will be dropped. So first row and the third row, this would be dropped. This is what we got. But we don't want the data to be lost, right? So this is the one of the way. So if you have a lot of data, you can go with this approach, but I won't suggest it because like we can always fill the data with the most possible values that can fit inside those empty places. So it's better to fill those rather than to lose the data. Okay, so now we are importing this, that. So we have intentionally added NaN values here. Again I'm doing drop now. So every column that has any value, like in any of the records, so this is a data frame now. Earlier we were dealing with the series object, right? So now what we are dealing with is the NaN object, right? Sorry, data frame object. So we have created a data frame that, so first record have all values, second record has NaN value in the one of the columns, and the third column has NaN values inside like every column. So if I did df.drop now, then all the records that have at least one NaN value, like if they have any if any of the column is blank, then those values will be, those records, the complete records will be dropped irrespective of let's say we have 10,000 columns and only one column is missing data, we will drop all of the complete row. that is not good. Okay, so if I did that, this means like okay, so what I did is here is okay. So what we're doing here is drop now. First index we are assigning nan. It's already nan. So let's try to fill this with the 0, right? So wait, this is what our df currently looks like, right? So the first so here what you're seeing here is the first column, that is like all the values in the first column are filled with the nan. Okay, so earlier we got the first so earlier we have a 2, right? But here we are specifying that for every column, so for every value in the first column, that is this one, there should be na, like the blank value. We are intentionally doing that. Okay, so we did that, and going forward, this is how our data frame looks like. Now earlier we used to do the drop now, like we were dropping records. Okay, but what I want to do is I want to fill, like I want to fill these now values with certain stuff, right? So here I use drop now, here I'm using fill now. So null values fill with 0, as simple as that. Like I fill 0. This is nonsensical right now, but if you know, let's say you have a column that is let's say gender, right? So you have a zeros or ones as of now in that column, right? So let's say you have 10 records. In 3 of the records female F is written, but 7 records are empty, right? So you can like assume like those 7 should be the male, right? So I can just type here those should be male. This is how we would clean the data. We will like have the data ready for our models to consume. Okay, so this is fill now, that is we filled 0. Right now if I did this, but our data frame, this is still nah, right? So this does not update data frame. This just shows like after doing this how our data frame could look like. Okay, but if we want to actually apply those zeros in place of NAND, we need to modify the data frame itself, right? So this is what we are doing here right now. So we are using fill now with 0 and in place is equal to true. So what in place here means is we need to like update those values in the data frame itself. You need not to like I need not to assign it, like I don't need to, I can do this as well. I'm sorry, I can always put this as well, but this should not be the right approach, or not the right convention. This should be the right convention. So we are using in place and we are updating. So now you see our original data frame has these values. Cool. So this is what I showed you, how to fill a specific value to the missing data, right? So, but that's not always the case. You don't want like you don't have a value to fill in, right? You don't want every column to have the same value. Let's say you have 10,000 records. For every column, if you are like going to fill a 0 or a 1 or a 5 or a 2, that won't be the good approach, right? We can do better. We can always do better, right? So this is our next example we'll talk about. So let's start with the more other methods that we can have to fill those missing values. So this is like, let's start with the front fill and then we'll go back, like we'll talk about the backfill as well. Okay, so this is the current data frame that looks like 1 2 3, the 1 2 3 and 4 NaN numbers. So here what I did is fill now, and method is specified as ffill. I need not to specify a value, I just specified how the data should be filled, right? So if I press enter here, I got, so you see front fill. So for this record, this is the front row, right? So this value should be replaced by this value. So if you see here, this line is replaced by this value. Same goes with this. So these values should be replaced by, if these are none, they should be replaced by the value, the column that is preceding them, like the front column, front row, I mean, okay. But let's say you have a complete empty column, right? So those old column will have the same values, right? So what you can say is, you can specify is, you can have limit. So let's say, so these two are NaN, right? So if I did this, the whole column got completed with the 2. So this gave 2 here, this gave 2 here, and so on. But that is not like, so those will have a skewed data, like only 2 will be present in this column, right? So we don't want that, because, so see, if every value in this column is NaN, then this column is useless for us, right? And if by doing front fill, every column will have a 2 value, that is also again useless for us. But front fill is useful if we have, if we use it with a limit. So this is the next example. If I use it with a limit, then only first occurrence will be updated. So if you see here, NaN got stopped, right? So this is NaN, so this is NaN, so 2 got here, but we have, since we have a limit 1, so they didn't transmit to here, so they stopped here. So that is the reason, like, so this is fine, but we still need to deal with this with other method or like other stuff. Okay, so this is front fill, back fill, drop now, fill now. Okay, these 4 are, I think, we have covered. Now we can always go with the mean as well. So let's say the second column's mean, we can have this. We got mean, so this is also like df second column, so I specify second. We got mean, we got the mean. We want to fill now with this, you can always do that, same stuff. So that's a fill now. There's endless possibilities what you want to fill in. Cool. So now let's start with the other example. So this is series object. Now I'm filling this with the mean. So if we have 1 0 and 5, that is 6 divided by 3 records. So while taking mean, we are ignoring the record completely. So so while taking mean, so we have 3 records, that is 5 0 and 1. We add that, we got 6, we divided by 3, since we are not including 2, so we divide by 3, we got 2. So here we are updating it as a 2, right? So this is also one of the methods you can use to do stuff. Same. So this is how you will be dealing with the missing data that we have. Okay, so I think all of our notebook has completed. I think we have covered that. So now comes the end-to-end testing part, the stuff that we have learned in these 10 notebooks. We would be applying this on the data set, and like completely we'll see like end-to-end how to analyze the data into the stuff. Okay, so I'm closing these tabs. right? So we have Google Play Store, uh, simple pandas, and the speeding ticket. I hope everyone is following or understanding. If anyone has issues, please let me know in the comments. So we will start with a simple EDA. EDA is nothing but the exploratory data analysis. So we'll be starting with that. Okay, let's start. Same regular stuff. We are importing pandas. Now we are calling our data frames as a games. Okay, we are reading that the same VG sales global CSV, that's the game data that we like started working on in the earlier notebooks. So I ran that. The data set is not present. Data. So we have read the data and told like you should treat our name column as an index. We are just showing the head, like how our data looks like: name, rank, platform, uh, year of release, genre, publisher, sales in different regions, and their global sales. So with the head we get the first 5 rows, with the tail and bracket 10 we get the last 10 records. So how to get the length of the complete data frame? You can just type len. So len is a Python function. So you can just type len games and we'll get the data. This will show you like how many records are there in the data frame. You can have the look at the shape. So this tells us this is the count of rows and this is the count of columns. So we have 10 columns here and we have 16,598 rows. Uh, so now, so we have a 10 columns, right? So we want to take a look at the data types of the columns. So what I did is games.data types. I would know like rank is an integer type, platform is a general object type, year is a float type, and sales are of float type. So I can always apply any of the numerical operations on these columns that have float or int values, right? So this is what it tells, and this is general example. So if you get the iLoc, so that I'm getting the location using index. So this is the index, right? So I'm dot iLoc, that means index location. I want that 299th index. If I type here 0, I get the first index, the first record that I got. This is nothing but this one. Yes, port. Okay, so this is how iLoc works. This is data types, how we get, and now, so remember we have our name column as index, right? So we can always refer to the record using these names. This is what we are doing here. So we are referring the like all the names that have Super Mario Bros. Dot as their name. So when I did this, I got this. Like name here, you can see Super Mario Bros. We had So remember we learned like we can sort our complete data frame using the index, using the like column names, using values inside the column. So this is what we are doing here. So we are sorting values by year in the games data frame. Okay, so by default it's in the ascending order. You can always specify it as ascending equals false. Then I'll get the latest one first. Okay, this is how it uh, looks like. Cool. Yeah, so this is the same example. Edit. I want our data frame to be, uh, let's say, have sorted based on the two columns rather than the one column, right? So first one is year. So first preference should be always given to the year, and second should be the genre, right? So and it's in the descending order, right? So first we got the year, then we got the simulation. So S comes after our same action, then we got the different year, same stuff, right? So first preference is given to year and then genre. You can always sort it based on the index. Remember, now our index is name, right? So we can always sort it index, but data has a junk values. So the ASCII characters that lies before the characters A, B, C, D would be given preference. This is solely based on the ASCII value. Okay, so that's an old, right? Uh, so I don't have okay. Clear. So now on the publisher, uh, we're just like the data frame, we can have a column. On the column we can have like so this is the column, right? We can have head, we get the first 10 records. Now comes the filtering part. So let's say you want to select all the games that have genre action. This is the condition that you build. So if I say this, right? So this will return a bool. You can see here. So for every record I get true or false, right? So this is the filtering condition. This filtering condition I'm applying inside this. So if I did that, I did this. Okay. So all the like all the records that have genre as an action will come out. Let me see. Yeah. So 3,316 rows are the total count that we got as for the genre action. Okay. And same. Games by genre. So okay, so this is the filter, right? This is the filter we created. Now we are saving this filter is in like as in variable. So we created a variable and we saved this filter. Okay, and we then applied the same filter in that. So earlier, like we used to write this inside this, but we are creating filter so that we can use that into the future. Like we can refer this just like this. We don't need not to write every time this. Okay, this is the same, right? Didn't see any difference because this is the same. This we are referring is this by this name. So let's start with the second filter. So we are creating games in 2010. So we have created a filter games in 2010, and now I'm combining these two filters. So this and this. That means we would only get action genre and those which are released in the year 2010. So this is the 226 records that we got. So in 2010, with action genre, we got 226 rows. This is what we can infer from this record, this DF. We can have just like the end, we can have or. So or means like union, and means like intersection. So this will have records which have genre, action, or like which have an year 2010. So this will combine this to form a single DF. That's why we got 4349 records. Same, we are getting another filter, and we are doing the same stuff. Games after 2015, I created a new filter. It talks about the game should be after 2015. Same stuff. Now the possibilities are endless. Just like the greater than equal to, we can have a between. So I want all the stuff between years 2000 and 2010. This is how it should do. So we should have column. We should apply like column. So instead of greater than or equal to condition, you can have a between function and pass these two values. So this would yield you the all the records that have those data between 2000 and 2010. So going forward, yeah, so this is what I want to talk about. There is always a need, like when you have to apply operations uh, by converting it. So let's say like you have year in the complete bigger format, like let's say you have year hyphen hyphen month hyphen uh, day, like day in words like Thursday, Friday, and date, every stuff. But you want only four, or like the first four characters, that is year, 2006, 2010, like that. So oftentimes you need to convert like this column into the string and then apply the operation, right? So this is what we are going to talk about. So right now we are taking the index column, right? So let's say this is the index, right? And we are converting it to the str, right? So this got str converted, type lower, like that. Every, so this means like every index would be first converted like, as in string, and then we would apply the lower function. Like, so you remember like from yesterday's Ishan's talk, like if you have a string, here R is capital, right? Okay, G. So this capital, K is capital, G is capital. What I can do is x dot lower, I'll do, and I'll get all the things converted to the lowercase, right? This is the same lower that we are using here. The same, like first convert to the string and then lower. This tells like all of the names should come as in lowercase, right? On that, I'm checking whether it contains spot or not. If it contains spot, then it's true, else it's false. Apply that. Okay, so look at that. Sorry. str lower should str contains. Also have str. Function apply. Yeah. So every time you need to check, you need to convert it to the str. So here I applied the function str, then I should again convert it to the str, and then I should check for the condition that I want to check. So right now contains is checking that sport word is occurring inside the name or not. If it is present inside the name, then it's true, else it's false. So the first record itself, I don't find there. Yeah. So the first record has sport in his name, right? So that's why we converted all of them to the lowercase, so that we can just directly check for the lowercase sport, right? We didn't specify anything here. We just check for the sport because we earlier we have converted it into the lowercase itself, right? So this is the condition. So this is also yield us an array of the true false, and earlier also we are getting this. So every filter will yield an array with the true or false, saying that you need to select this record or not. Uh, so we selected this array. Then this is to just to showcase you. Okay, doing that. Now the filter is created. What I'm doing here is I'm applying this to the games, and this will select all those names that have sport in its name. Okay, this is you see here sport. So this is the final output that you will get here. Now, so these are the categorical values like the uh, text stuff, right? So we also have global sales, right? These are the non-categorical values. That means these have float and int values, right? So if you want to get the mean of the any of the column, just do this and you will get the mean. Same STD, standard deviation you will get, and all the other operations you can directly apply using the column. So this is okay. So earlier I was talking about the group by, right? Okay. So let us see that is working. So here we have group group the complete data frame by the genre. Okay, so we have a 12 genre, right? So, then, yeah. So we have these 12 columns, 12 values inside the genre. So what I did is I grouped by and I tried to find their combined sales. So I want action figure. So I want a genre-wise distribution of the global sales. Okay. So I did this, and I'll get this. So you can see here, based on the action, like so, action genre has the highest global sales than in comparison with any other genre. Like you have adventure fighting. So what it did was like firstly took a data frame, grouped them by their genre, like collected all the records of the action as a separate, collected the records adventure as a separate, fighting as a separate, miscellaneous as a separate, and then calculated the sum of the global sales. This is what it does in a nutshell. You can apply value count, sort values, any thing you want, like ascending, descending, any stuff. So this will tell us like how the revenue distribution according to the genre. So this covers the simple uh, EDA. Now we'll be moving with the Google Play Store and speeding ticket, and lastly the visualization part. Okay, these are the three notebooks that I'll be covering. So Satya here. Yeah. I'll be having like a 5 minutes break, so if that's not an issue.
Yeah, sure.
Yeah. So we'll meet back in 5 minutes. installations and type whether it's a free or a paid. If paid, how much is the price, content rating, gain genre, last updation by the developer, current version number, Android version it supports. Okay, so this is how our data would look like. So let's start by importing this. So we have imported data, all the columns we got. Now we are going to understand. So first have a look at all the columns, that is app category rating that we just saw. So df.columns will yield you all the columns, column names. So this is what we get. Remember I like mentioned earlier that column which have a space, column names that have space between their names, that would be an issue for us. Like we can't refer it using the df dot that name, right? So it is a good approach to first clean these up. So here what I'm doing is I'm replacing the spaces inside the names of the column header with that of a underscore. Okay, this is the same, like df.columns dot str replace. So str conversion is mandatory, and then replace, and then I have space with like you can say uh, underscore. Underscore would be the best, not the simple hyphen. Okay, so now if you again go to the df column, so yeah, this needs to be assigned to the other columns. So df dot columns is the way like you are going to assign column names to the your data frame, right? So here what I'm doing is to the data frames column, this should be the new names. Okay. So if you see again df.columns, you would see that last updated columns have underscore instead of the uh, like the space. Okay, so let's take a look at the data frames shape. That is like the number of rows and the number of columns. So it has 10,841 rows with 13 columns that we just show you. Like this is the type of the columns. So only the float one is in the standard format, else all are in the generalized object format. So now we are going to deal with the missing value. So first we need to find out like if this data has a missing value or not. So earlier we used to do isNull on the series, right? But if you do it on the df, you would have isNull applied to the every column that the data frame has. So this has a, I think 13 columns, yeah. So on 13 columns, this applied isNull and took the count of that true, that is the number of null values. So the only rating has these 1474 values out of 10,000, and rest all have just a couple of values missing, and else our data is completely fine, right? So let us visualize how our data is like missing. Okay, so Seaborn is a pretty good library. Seaborn and Matplotlib, these two. So along with pandas, every time like you are doing data visual, you are doing the EDS stuff, you will need those two as well. Seaborn and Matplotlib. So Matplotlib is the standard. Seaborn is used like for some advanced type of stuff. So so the good point of the Seaborn is like it has a complete layer of abstraction. So you need not to do anything. Just type what you want, the type of graph that you want, and boom, that you will have your graph. Okay. So here I'm importing Matplotlib and Seaborn and setting the theme, and this is the DPI, that is nothing but a dot per inch. So higher the value, the sharper, the crisper the images. This is nothing but the figure size, that is the row and the like the column. So length and the width of the width and the length of the figure. Okay, so here if you see here, we have plotted this heat map. um, which represent, so white here lines represent the missing values. So you see here we have some of the missing values in the current version, but majority of the values that are missing is in the rating column. Okay, so I'm going to use the median value for the missing data in the rating column because that is the best approach that we can have. Median is like the middle, everyone knows median, right? So median would be the nicer choice in this as compared to the mean, because if let's say we have like majority of the ratings like skewed on the other side, right? So let's say uh, on either side of the URL of the scale, that is 0 to 5, right? We have a 5 rating, right? So what would be the best, like what you want to average out, or like we can have medium? So we would go with the medium. uh, then so here we calculated the median for this. Let me show you first what this came. So remember we have the mean, we have median, we have standard deviation, and all the other stuff that you want to do with the non-categorical columns. You can do this in this notebook. Uh, so here we got the rating median. So median value in the rating medium, we printed it, that is 4.3. And what we are doing is we are filling the now values, like null values, with the rating median, and we are doing it in place. That means we need not to write df is equal to this df, right? This would do in place itself. So this is pretty much like fill all the null values, and rest all we can drop because those are like pretty 5-6 records, right? So these we can drop, so we are doing that. I don't know why we got some 2 times here. Now if we check, we don't have a null values because so earlier we have a null values, right? So this we have filled with a median. This record we have dropped, so 1 record we have dropped here, and 11 records here we have dropped. Okay. So these are the so we have 11,000 records almost, so we can drop some of the records, so that should not be an issue. So we got here. Now our data is cleaned. Let's get the info. So just like the describe, we also have an info function that tells a general overview of the data frame. So this tells us like all the columns that we have here. We have how many values, their normal their null and non-null count, and their data type. So these help to generalize, like to find like what needs to be done. So if you want to process this further, you can always process them. So let's process with the data processing. So till the time, like till this point, we have covered data cleaning, that is the handling the missing data, and understanding. Okay, so start with the data pre-processing. So this is the review column, right? So we are doing describe. We got the description, like this many count, unique total unique values is 5,999. Most frequently appearing value is 594, and that is the 0. So most people have like this many people have give them the 0 rating. Remember, so this is not 0 1 2 3 4 5. This is like let's check this how. It should work. Would be better. No. So these are reviews, these are not rating, right? So on the most apps you don't have rating reviews are done by the user, so that's why it is saying 0. Okay, so I thought like it was a rating of star, like 1, 2, 3, 4, 5, but no, this is a review column. Rating, I think we have a different one. Yeah, so rating is a different one. Okay, so review column describe. Yeah, so this is the column that has a numerical value, right? So this should be as of type integer or float. But we so review should be in integer, right? So there should not be partial reviews. So this should be an integer value. So we are specifying here. So till this point, our data type is of object, right, on the reviews. But when I did this, so df reviews is equal to, we are assigning this as type int 64, that is integer 64 bits. So when I again did this, now I got data type as a float, and you see how our describe format changed from this to this. So this is the reason why we want our columns to be in a particular format. Like if those are non-categorical, we should want that key. We should have those their data type as an integer, not as an object. Because see, if we have integer and float, then there are other possibilities that we can do. Just like the describe, we got the information. Else it was missing for us. If we did review column as an object, right? So this is to showcase how to convert to any column to the particular data type that you want to convert. Reviews integer is the most sensible one and it should be used, so that's why we took that. And now size column. So this is the size column. So unique values we have 457. So this is size in nothing but the MBs, like the MB that we have, like how many, what is the size of the application. So this yield you the unique. So okay, let me start part by part. Did that wrong? Yeah. Df size dot unique. This will give me the unique values in the uh, df in the size column, right? So what if I did length of this? That length of this, then we'll get the length, that is 413. So this is a unique value that is present in the size column. So if I close that, and here I'm just printing this. So unique values for 413, and what are those unique values? These are the unique values. So let's remove m and k in the size column. So what we are doing here is, on the size column, apply this dot replace m with blank, k with blank, regex is true, I'll explain what is this, and in place is equal to true. So in place you already know, like I need not to assign it, you just update it in the original data frame. And regex is the journal, like we always this is nothing but the regex operation that we use is, right? So right now we are just replacing the string, so we don't need that, but like I always replaces using the regex, so that's why I always write regex here, irrespective of I'm using. So if I'm using here star and all the stuff related to the regex, then this should be the case. We should have regex is equal to true. Okay, it's fine. So if you go down here, and now we see here the unique count, it's still the same. So let's replace the string that depends on device. So here we got varies with device, right? So in this numerical data, we have just one outlier, you can say bad value junk data. So we would be replacing that with the median. So to do this, we first want to calculate the median of this array without this. So we need to first make an array out of this, delete this element from it, calculate the median, and then replace this with that value. Okay, so this is what we are going to do it. So let me explain this in. So this is nothing, we have created a filter. Okay, this is nothing but a filter, we created filter. So this would only be uh, false for the record that have uh, size value varies with the varies with device. Yeah, so else all would be true. So here what I'm doing here is I'm selecting all those records and which don't have those which don't have varies with device as its own size value. Okay, so I created this filter. I This is the filter. This is the data frame that is selecting all those records except for this record, and then for the data frame, for the new data frame that we got, I'm selecting the size, converting to the float, and calculating the median. So this would give me the median of the column. So I need to run it, start, and so till here we got this, right? So earlier it was giving us error because I first ran the complete notebook and it was not able to find this, so that's why. Okay, so leave that. So till the time we have now reached here. So we are selecting all the records except the record that has this as its size value, and we are converting that to float and then calculating the median, right? So we got the median as a 15, right? So this is this is how we get the median, but we need to replace those value in the original data frame, right? So I'm reading that. So size replace varies with device, and size median that we just calculated, and in place 2. This will do the same. So now we can convert this size to the numeric. Earlier we can't because we have bad data, but now it is converted. So if you see the head, this, now we see the describe. We are seeing the complete as in non-categorical answers. Okay, so this covers the handling of the size column. So data pre-processing part is done for this data set. Let's move forward to the install column. So let's find out what does it say. So first we are calculating how many the unique values is there. We can also have n unique, which would tell us how many count, like what is the count of the unique values. And now like we check the data type. Data type is of object, but that can be an integer, right? This is what we are going to do. So we are replacing plus with a blank value. we are replacing comma, that we have comma here with a blank value, and then we are converting that number into the integer number. Okay, and what we are doing here is, okay, so let me tell you what this does is. So start one by one. This is the lambda function. Okay, the single line function that I talked about in the first half. So this would take x as an input, and it will revert x dot replace this. So after reverting, like replacing plus with the blank, it will revert the value. So this is what we are doing, what this function is doing. Okay, and what here I'm doing is I'm telling for the data frame we have an installs column, right? So one of the column is installs. So on that column you apply what? Apply a lambda function. Okay, so on each record on the install column, so install column has records, right? So first, second, third, fifth sub values, right? So for every value you apply this function and save it in the same column. Okay, so this is what I did. I'm applying on the install column a lambda function that replaces plus with blank, that replaces comma with blank, and then converting that number to the int. Okay, so these are the three operations that is applied. So I did that. Now unique, you see here commas are gone and plus are gone. These are pretty cool format. Now if I type the data type, we get the int64. Remember earlier we are getting the data type as an object, right? So we can have a describe and all the functionality and all the stuff, all the operations that we want to do, we can do this on this data frame, on this column. So let's start with the price column. This same, let's find out how many are the unique prices. Okay, so here we have a dollar, so dollar is understood, so I don't think we need that. So we're doing the same operation that we did here. On the column, on each record I'm applying a lambda function that is replacing x, the value that is for each record, replace that value replace dollar with the blank. So in that value replace dollar with the blank and then convert it to the float. Same stuff. Price unique, and if I get the d type, it will float 64. Okay. Now I think this is the final column. Okay. So genres column. So same stuff. Let's find out how many unique values we have. 119. Get the head, art, and all the stuff. There is divided in genre, sub-genre. So let's only set by genre. So we are splitting using the yeah. So now have a look. So what we are doing here is we are taking the genre column, converting into the string, splitting it based on the semicolon. So let's say if we have this, okay, let me give you the example in this. Better if you understand this. HJ unique pair. Yeah. So this is a string, right? So now what I'm doing is HJ dot split based on what? Based on semicolon. When I did split, I got an array. So I applied split on string and I got an array. So this is what we are doing here. So on this we are doing the split and selecting the first one. So if you see dot str 0th, So this like art and design we are selecting, we are ignoring pretend play because we want genre, not the subgenre. Okay, so this is what we are doing here. Uh, Again, we are getting uniques. See, here we are now got from 119s we got the 48. Uh, so now let's look at what are the unique. This looks fine. Okay, so let's combine music and audio with the music. So if you see here, we would find music and audio. This one with the music one, which is where this one. Okay, so let's combine these two. So we are replacing music and audio with the music in place is equal to true, and that would handle self. So we have data frame, we have last updated column, last updated, remember, we are going to convert it into the datetime format. Right now it's not, is in the object format. So last updated we got head. Yeah, so pd.toDateTime. So this is the function. So this tells pandas like in our data frame, this is the a column that have dates in it. So you need to treat this as in date, not as an other object, not as in string, not as in float. This should be treated purely as in date. So pd.toDateTime data frame last updated. This is what we did, and here we got head. So see you format will change, and if I do play here, and you see here. So now this is of a datetime object. So by doing this, this is easy. Like we can have multiple operations that we can do. Like we need not to use the regex to apply to get the year, to get the month, to get the day. We just use this column dot dt dot year. We get the year. Dot dt dot month. We get the month. Like that. So now comes the main visualization part. So this is the main part. Till now we have our data ready. So this is the 90% of the work that you will be doing. Right? Last 5% is your visualization, and the rest 5 is just to create a model and feed the data to the model. So, so firstly let's start with the box plotting. Uh, okay, so let's start with the bar graph first, then we'll go to the box. Okay, so this is the bar graph. Okay, so bar graph would be only applicable to the categorical variables, like the one that have less values, right? Okay, so let's say we want to figure out how many of the apps are paid and how many are the free, right? So what I did is, let me show you this first. So I'm doing the value counts. So it says 10,032 apps are free and 797 are paid. So I'm using this to plot. Remember, this is nothing but a series object, and we can apply directly, we can plot directly graphs on those series and data frame objects. So you just need to type the plot, like mention the type of the graph that you want. Right now I want bar, color. You set the title, and voila, you got the graph. It's pretty big. So free, paid, you get this. I can always reduce the size, but okay, let's. This is how a graph would look like. Okay, so let's start with the box plot. So I think this is the most important graph that I work with. So let's understand what does this figure says. Okay, so we'll do this for the rating. Okay, so let's see, explode rating. So here this is for the paid apps, and this is for the free apps, this is for the paid apps. Yeah, free and paid. Okay, so what does this represent here is, okay, yeah. So the quartile, I hope like everyone is aware of the percentile, how percentile works. This represents the same. So you are seeing here, this is for the free, this is for the paid. Let's talk about the free first. And from this to this line, 25% of the values lie. So if we have 100 values in our record, so first 25% lies within this range, that is 3.5 to I think 4.1. Okay, rest 25% lies in this to this range, just a small range, 4.1 to I think 4.3, and same 25% like from next 25% lies in this range, just in the 4.3 to 4.5 range, and rest 25% lies in the 4.5 to 5%, less like last 75 to 100 percentile range lies in this range, that is 4.5 to 5. So four separations we have: first this one, second this one, and third this one, and fourth this one. So these four like represents the first quartile, second quartile, third quartile, and the fourth quartile. Quartile is nothing but just the percentile division: 25th percentile, 50th, 75th, and the 100th. Right? And this tells us the outlier. So the dot that you are seeing here, these represent the outlier values that we have. Like some of the values are outliers, right? So outliers basically means uh, unexpectedly low or a higher value. So let's say you have a graph of 1 to 100, right? 1 to 100. So most of the values are lies between the, let's say 40 to 60, like let's say out of 100. So graph is on the scale of 0 to 100. On the scale of 40 to 60, we have a 10,000 values that is lying around, and rest 100 values are split across let's say uh, 0 to 10. So those 10, so the values, that 100 values that sits inside those 0 to 10 range, that are our outliers, because they don't follow the general trend, right? The general trend is to have into the 40 and 60, between the 40 and 60, but those are outliers. So these represents those outliers. Okay, so we are plotting the block plot for the different uh, graphs, different columns. So this is for the content rating. So this is the counter plot. Okay, so content rating, we have of 6 variables, right? This is kind of bar graph tilted around, but this is the SNS way of calling the bar graph. So SNS is nothing but like we have imported SNS as in Seaborn as an SSS, right? So uh, this shows us like in the content rating, so everyone content rating has maximum records, that is 8700, followed with teen, followed with mature, everyone adults, unrated, like this. So we can just plot it. Box plot for the content rating, same stuff. You can have for every content rating for every one team. So you can plot how many values it lies, like how many ratings those categories are getting from like first percentile, like first 25% of the ratings are occur here, next 25 here, next 25 here, like that. Now one of my favorite graphs, that is a scatter plot. So scatter plot is like just plotting the exact points. So if we have just specify, so SNS is, so C1 is pretty like abstract library. So I just gave the data frame here and mentioned the category and price. Okay, so these are the two stuff that I mentioned. So what it did was, so it plotted category on the y-axis and price on the x-axis, and then like it is showing like for the this category, most of the apps have a zero pricing, right? So you can see here zero pricing, but for this category, that is family, that is lifestyle, and that is food and drink, so these are paid apps, and this is how the distribution is. So every dot represent each point, so there should be a 10,000 dots, so these are overlapping, like on the zero, so most of them are zero, right? So those are overlapping, so these are 10,000 dots, like the number of records that we have, so these are the same count of these dots. So you will be mainly working with the scatter plots and bar graphs, scatter plots for the like the price, like non-categorical variables, and scatter plot for the bar graph for the categorical ones. Now comes to the heat map. So this is also a very useful graph that we get. So if I do this, so everyone has like everyone knows in the how a proportionality works. Like we used to study like force is directly proportional to acceleration. Like the amount of force is applied, so acceleration is directly proportional to that. So this is, so that proportional is correlation. Like F is equal to F is directly proportional to acceleration, right? Force is proportional to acceleration, right? So here what we are referring is we are saying is force is correlated to acceleration. फोर्स ज़्यादा होगी, एक्सेलरेशन भी ज़्यादा होगी, फोर्स कम होगी, एक्सेलरेशन भी कम होगी, right? So these are directly proportional. What if I say F is equal to 1 by A? That means if I apply the force, then acceleration will decrease, and same if the acceleration is high, then force will like be less. So this is the correlation part. So you are seeing here is correlation. So I'm like testing here like so all the categorical columns are listed here. So if you see here, like same columns, rating, review, size, installs, price, same columns goes here, and this shows how these columns are related to each other. So let's say this rating example. So rating column has hyphen 0.02, 0.05, nothing, so 1. So as long as I'm sorry, I misspelled age, so it should be height and weight. So as long as like height is increasing, so general trend says weight should also increase, and vice versa, general trend. Okay, so this says us like these two columns are related, so we can infer that like these two columns are like closely related. So let's say if we have two unknown columns that are completely related, that let's say here the correlation value we are getting as 1, that means those two columns are entirely related, and one of the columns is unnecessary in our data set, and we can remove that, right? So the columns that have a higher correlation, we can remove that, because like those two represent the same value in the end, right? So that is like heat map, like that confirms that theory. uh, you can always plot histograms, the one of the best things in the graphs. So So just type rating. Histogram is the values, right? This is applied in a single column, unlike these all the stuff, all the other above graphs. So what I'm here doing is I'm plotting a histogram for the ratings, right? So what it is doing is it is creating a bins for every. So here okay, so this is it. So this creates a bin. Okay, so bin means bucket. So in that bucket, in that range, if values lie, so for 3 rating I've created a bucket. For this we have bucket. So like it is infinitely small. We don't have okay. So I'm talking about the binning. So histograms works with the binning concept. So what binning means is you create a bucket and bucket of a range. Let's say I've created a range of 10. So it is irrespective that values lies at the first or the, like let's say we have a range of 0 to 10, 10 to 20, 20 to 30, right? So 0 to 10 we have a one range. So irrespective of, like let's say 100 values comes for 0, 100 values comes for 5, and 0 values comes for 10. But that bin is from 0s to 10 range, right? So on that complete bin, that would be the uniform. So that bin will have like all those summation that will tell us like इस range तक इतनी values हैं. So this helps us to segregate like how many reviews we are getting. So we are plotting here like that. Here actually bin size is pretty small, that's why you are seeing that. So this is histogram. So SNS has its own histogram. You can plot histogram with the direct data frame or the series data. Anything like you can proceed further. So this covers our EDA on the Google Play Store data. This is also wrapped up. This is covered. Visualization part we can cover. So let's take a 5-minute break and I'll just continue after that.
Okay, sir. Okay.
That's it. So tomorrow we will dot is null dot sum, right? This is what I did. I got the count, right? What I did was I took that, divide the count by the length of the df, then multiplied it by the 100. Okay, this would give me the same answer, same results in the percentage. So this says like 96 per the values in the search for reason is missing. Same goes with this, that, and this. Okay. So these columns are pretty much useless. So let's work on the date column. We haven't seen that date, right? So let's start. So we go to the head, but this is object is still of date type, object type. It should be of date time object, right? So this is what we are going to you know modify. So columns, these are all the columns, and head, got the date, we got the time, head, and now what I want to do is I want to just if I want to replace the change the name of the columns, what I can do is df.rename and columns is equal to pass a dictionary. Okay, either I can pass a complete list that will have those aligned, like this will modify all those names, but if I want to change only those two names, then I can just have a date and a time. Okay, let's say I do want to only modify these two, so I want to date and time to time, and then the important thing is I'm doing this in place, so I need not to assign it. I just type in place is equal to 2, so original df will get updated. So if I do this, we got the date and time. Cool. How to get the first rows, first 5 values. The first record, we got the first 5 values, that is first, second, third, fourth, fifth, not split age to the service area. Okay, so row number, date, time, service area, first, second, third, fourth, so this is object age. Object age. So this is head. So if you want all the values, have complete same stuff. If you want to get the 2 records, all okay, so no. So this is this it's not 2 records. So yeah. So if I'm doing for the first 2 records, what I want is I want the first index. So that is the first index is nothing but the date. So I'm getting the date for the first 2 records. I can do this with the row number as well. 0. You can have a row number column. Okay. Here we are getting the first row and the first column, that is the date. Same first record, first, third and fifth column. First to fifth record, 1, 3 and fifth column. In the ilog, same again. I can have a, so I hope you all knows this. This is nothing but the string slicing kind of stuff. So you can just, you need not to write 1, 2, 3, 4, 5, 6 specifically. You can just use those colons and all the stuff used in the string slicing or list slicing to have the data that you want. Now this specifies, so here we are specifying with the index, right? Now we can, you can also specify with the column name, that is you want from time to type, right? So first to 5 record, you can do this, and same like first to 5 records, date till type, head, just want 5 records, like that. This is nothing, our standard function like to calculate the sum, which we did earlier. And now these 2 important terms. So drop now. Now I am specifying how all. Okay, and here I am specifying all how any. Okay, so any column that has like, if they have like they are completely null, then this would drop that column from the DB. So what I mean by that is, imagine we have an Excel, right? In that Excel, let's say if any column has all of the values missing, then this will drop that column. If like let's say we have a 10,000 rows and only one value is present, then this won't drop that. And this is the opposite of that. This will drop uh, any column that has at least any like null value. For example, let's say we have 10,000 records, and in a column we have only one missing value, and we have 9,999 rows populated. So this will like still remove the entire column. This will drop the entire column. So we are not doing this in place. So I'm just showing you. So originally. So additionally we have 19. So how old? So in any of the column we don't have like the complete blank. There are some values, so this didn't change it. But if I did the same with this shape here, see only three columns so here you see like only three columns are left from the 19 ones. So it removed all other 16 columns because only three columns are there which have a complete end-to-end data. So else got completely removed, you can say, right? So now let's say we can have a simple insights by looking at the data. So we have a df dot columns and reason for stop. So we have a variable that is reason for stop, right? So what I'm doing is I'm doing the value counts and then the heads. So heads and the value count. So this shows moving violation is the maximum occurrence. Moving violation has the maximum occurrence. If I do the head, so I get the most 5 first occurring values. I got this, so delete. Now, so we want to have this. So what here I'm doing is I'm creating a filter, again a filter. So if I get this is nothing but a filter. So I'm checking like get me the records for which on which reason for stop is moving violation. Okay, get me all those records, and uh, this is what we got. Okay, these are the old records that have moving violation. Reason for the reason for stop is moving violation. So I want to know the subject sex value count. So let me normalize it afterwards. First do it right way. Male has this many and the female has this. If I normalize it, I get the percent. 2% of the moving violation is done by the male, else all will be done by a female. This is from the data by just looking at the data. Now, if you look at this, the second example, we are doing the same. Like now we are checking for the female, only a female. The reason for stop value count. Okay, so here we are creating a filter that has just females. Okay, we are not we are getting all the records for the female, and we are checking the reason for stop. Okay. The violation, like crimes related to moving violation, and 21% is the equipment and all the other stuff. So this is like how you can uh, infer the insights from the data, right? So now so now arrest mates value count the same we are doing to the arrest mate. So this tells us like how many of the arrest mates for these cases. So 4 tells us no arrest made, and this tells us arrest mates. So if I normalize it, so that 98.6% cases arrest was not made, but 1.3% cases arrest were made. Now we are using the group by, that is again useful. So we are grouping on the basis of male or female, and then arrest made, and then value count. Again, we are normalizing it as well. So this tells us, like for the female, right? So arrests were not made 99% of the 99.1% of the time. Okay, but for the males, this drops to the 98.35%. So in the male, 1.6% of the time arrests were made, and in the female, only 0.89% of the time arrests were made. This is the general insights that you can get from this data. So remember, we have now columns as date here, right? Date. So here we are doing the same. So we are using df date string में convert कर रहे हैं and then slicing. So we are slicing it to the first 4 values. So let me show you what this looks like first. Don't yield till I do stuff. Slicing, slice just cuts down the string to the first 4 characters. So I can do this as 6 as well. We get these 2 characters, maybe 7 characters. Yeah. This is string slicing. Okay, I lost notebook. Yeah. Now we are doing, like, we are just taking the first 4 that would yield us the year, and on those we are doing the value count, so that we should know, like, in our data how many records are associated with 15, 16, 17. These are the stuff that like endless possibilities understand the data. This is the part 1 of the models, right? So maybe year is important for you, and like month or date you won't care. Then you would just rename, you just cut this date column to the let's say year, or maybe month. Like if you want some insights from the month, like how the sales grow monthly, all this stuff you can do. So we're doing separation here. If time, so here we are combining, and then combining below top date time. So this here what we are doing is we are, I think, combining. Yeah, so we are combining the data, so a datetime object in the Python refers to the exact timestamp that includes date and time, but the data that we get is of like one column has a date and one column has a time value, right? So what we are doing is we are combining these two, clubbing them, and giving to the pd.toDateTime. So this will like make it as in timestamp. So if you see here, this gives the proper format. So this is the proper format, and if I did here d types, you will get the date time. It means this column has entire information regarding the timestamp, whether it's day, whether it's date, whether it's month, whether it's year. Yeah, so this is the thing that I was referring to. So if you want to get the month, just type data frame columns name dot dt. We do the str, we do dt here. You want the month, you type month. You want the year, you type year. And let's say first 5 records, you get the answer. So this is the stuff that you can do with the datetime column. The datetime column is pretty useful, so always try to look for the datetime column that you can convert, and then convert it, and then your life will be easier, like you can manage all the stuff. So arithmetic checking, this is a type object, but we want it type as a bool. Let's convert that. Arithmetic, now it's this, and now so now what we're doing here is okay. So this is the interesting insight that I want to tell. Group by the date time, and then arrest made. Okay, so I think that would come here, right? Okay, so here what we are doing is we are grouping by based on the R that they would be arrested. Okay, and then I'll meet. This is right. So we are grouping by based on the R, and then arrest mates, and then its mean and the first 5 values that we get. So if we did this, for the each of the R, we get the mean value of the arrests that were made. So, so generally you will get this. Let me rearrange this. So for every R, so you can see here like this is 0s to 20, these are R's, and these are the mean values. So if you add all these, so this will tell you like percentage wise. So if I can this here, yeah. So 10% of the arrests were made on the 11 p.m. and like 15% at the 8 p.m. and these were in the nights, and like lesser in the morning. These are the stuff that you can tell by looking at the data. So this is the magic line that you should have if you don't want to use PLT. So remember, while plotting the graph, you need to always use PLT.show to plot the graph. But if you have this line in your Jupyter notebook, then you need not to do it separately. It will just type the graph plot. You need not to type the show. Okay, so these are the simple graph, like the bare minimum graph that you can have using the data frame itself without the Seaborn or Matplotlib. So group by, again R's, and like arrest mates, mean, and then plot. We are doing the same stuff. We're plotting the graph. So nights it has higher, and in the evening it got higher. So this is just like that. So if we do the value count, we can infer that so these are the so most of the records are from the late nights, that is okay. So early morning, so maybe this is because people are traveling to the office up, and that would be the time that they would get the ticket, like the speeding ticket. So this is like we can infer. And yeah, so I think this pretty much sums it up. Lastly, stop. Okay, I think we have plotted this earlier. Yeah, so this is plotted. So this sums up. I will leave with some of the notebooks that you can try. So this has a couple of other data sets. So just like the Forbes 2022 billionaires. So you can have a look at this. The IRIS data set, this is quite popular. So actually My notebook will cover that. So I have a couple of notebooks that will have a graph, but those are just the graphs. So take a look, and if you got any issues, feel free to ping or uh, reach out to me. That's it from mine. Satya, you want to continue?